Okay, so now we're going to talk about a practical problem in lifting a heavy weight. Jacks actually have built into them, any kind of a hydraulic jack, it's got two cylinders built into it. It's got a big cylinder and a little cylinder. When you press down on that little cylinder, it generates pressure that then goes into the big cylinder, and it multiplies your force by you pressing down with a small force, and that pressure then is used to generate a large force. That's what's called a force multiplier. It's how all jacks work, right? So this particular jack has got a 10-inch lift cylinder. That means its big cylinder, the one under the car, is 10 inches. It's got a 1-inch pressure cylinder on the jack handle. That's the small cylinder. How much force is needed on the handle to lift that 2,000-pound car we talked about, which is kind of light for a car, right? So let's draw this before we do the actual math. So I've got a big cylinder here with a car on top of it. All right, I'm going to draw the car. There's my car. The car weighs 2,000 pounds. And please, guys, remember to always draw these. All right, then I've got a small cylinder here with a jack handle. And this force is what we don't know. This is 10 inches, and this is the diameter is 10 inches, and this is 1-inch diameter. Now, here's where a lot of people get wrong. And by the way, these are hooked together by a hose. So one thing that you guys haven't learned yet, but you're going to learn soon, is when you have a system all hooked together by hoses, pressure automatically equalizes as soon as the system becomes stable. That means the pressure here is the pressure here is the pressure here. Pressure is the same everywhere in this closed system, as long as it's not actively moving up or down. Okay, so the rule of thumb is PSI is constant in an enclosed system, no matter where you measure it. All right. So let's talk about the formulas we're going to need. First of all, I'm going to need to calculate these areas, because your force multiplier is not 10, right? A 1-inch diameter and a 10-inch diameter. A lot of guys jump to that conclusion. Like, all right, I just multiply by 10. So over here, I'm pressing down with 200 pounds. Wrong, because the relationship is not based on the diameter. That relationship is based on the area. And there's a lot more area in a 10-inch diameter cylinder than there is a 1-inch diameter cylinder. A lot, way more than just 10 times. So don't fall for that trap. A lot of people do, especially, I mean, even me, if I'm working fast, sometimes I don't even remember that. Don't fall for that trap. Don't look at the diameter of the cylinders and assume that's your force multiplier. It's the areas. So let's look at the formulas we need. The first formula is I need to calculate the pressure inside this entire enclosed area. I know the force being pressed down here, and I've got the diameter, so I can calculate the area. So the first formula I need is the area. Area equals pi r squared. The second formula I need is the pressure inside here, and pressure is equal to the force divided by the area. Then once I have the pressure in here, once again, I'm going to need to know the force up. So I need to know the area. And I'm needing to know the force is equal to pressure times the area. So I worked the problem around through the system. All right, so let's figure out the two areas first, because I'm going to need the areas for both of these cylinders, like automatically. So the radius is, the diameter is 10 inches, so the radius is 5 inches. So 5 by 5 is 25 times 3.14. So my area is equal to 78.5 inches squared. That's a lot of square inches. Over here, 1 inch. So my radius is half an inch. So 0.5 times 0.5 is equal to 0.25 times 3.14, which means my area is equal to 0.785 inches squared. Okay, so I got my two areas. But look at this, guys. Look at this. The relationship here looked like 1 to 10 if I just look at diameter. But if I look at areas, it's more like 1 to 100. Roughly speaking, 100 times, not just 10 times, 100 times the force multiplier, 100 times. If I just look at areas, I can see it's 100 times difference. So let's see if that works out when I figure this all out. So now that I know this area and I know this force, I can plug in this formula. 2,000 pounds divided by 78.5. And so let's get out my fancy calculator. 2,000 pounds divided by 78.5 is equal to 25 point, well, I'll just round it to 25.5 PSI. That is not a lot of pressure. That's because that's a giant 10-inch cylinder. It doesn't need much pressure to hold 2,000 pounds. Whoa. But now I know my pressure. And because I know that pressure in an enclosed area is constant, I can go over here and plug in the values. So force is equal to 25.5 PSI times 0.785 times 0.785 equals, my force is equal to 20 pounds. Bam. That means all I have to do is push down on that lever with 20 pounds of force. Not a whole lot. I can do that with my pinky. And I can lift a 2,000 pound car. So my multiplier is indeed 100 to 1 ratio. And the way you figure out the ratio in these lift systems is you look at the ratio of the areas. You see how that worked? This was complicated. There's a lot of steps involved. But the first step is figure out the areas. Then you work your way down one cylinder to figure out the pressure. And then you work your way up the other cylinder to figure out the force required on that second cylinder.